Good morning, student. Myself Manoj Kumar. Today I am going to teach you the physics of your class, and today I am going to explain the force on a current carrying conductor placed in a magnetic field. Means when a current carrying conductor is placed in between the magnetic field, that conductor experiences a force. For this, an experiment was described that is called kicking experiment. In that experiment, what we do, we take a metallic small plate filled with mercury in it, liquid mercury. You know that mercury is a metal and it is a good conductor. And one end of this is connected to the battery, and a straight wire is dipped simply in this liquid, and that other end of the wire is connected to the other part of the battery. Now, you know the children that this wire is simply dipped in this liquid mercury. Now, when the current flows, let us see. Now, you know that this wire is simply dipped in this liquid mercury and it is not fixed here. This end is free to move. So, what we see, when current flows through the circuit, then what happens? This wire get flicked out of it. As you have seen, that when the two wires are loosely connected and when electric current passes, that loose wire starts sparking. In the similar way, when the current passes through this wire gets flicked out and the circuit breaks. But when whole of this system is placed under a strong magnetic field, when the whole of this is placed under a strong magnetic field, when the whole system is placed under the strong magnetic field, then what it was observed, when the wire flicked out, this wire again comes in the liquid mercury and again it flicks out. Means it will move to and fro. Means once it flick out, again it comes back to the tubelet inside the liquid mercury and it start flicking out. This shows that whenever a current carrying conductor is placed in a magnetic field, that magnet also exert the force on that conductor. That's why so that force on a current carrying conductor placed in a magnetic field. Means when this setup was not under the magnetic field, what it was observed, once the wire flicked out, the circuit breaks out. But when this whole setup was placed in the magnetic field, and again the circuit starts when the key is closed, then current flows through the wire and again this wire flicks out and again goes back to the liquid mercury. It means that some force is exerted by this magnet which pushes this wire again into the liquid mercury. This is called kicking experiment. So this experiment shows that a force is acting on a current carrying wire when it is placed in a magnetic field. On the basis of this, the Fleming has given a rule that Fleming has given a Fleming's left hand rule. Means when you stretch your left hand in this way, thumb, forefinger and the middle finger, in such a way that these three fingers are mutually perpendicular to each other. These three fingers are mutually perpendicular to each other. If the forefinger shows the direction of magnetic field and the middle finger shows the direction of current flowing in the conductor, then the thumb will show the direction of motion, or you can say the direction of rotation of the coil. Once again I am repeating, as per Fleming's left hand rule, because the force exerted by this current carrying conductor when placed in the magnetic field, that direction of force is determined by the Fleming left hand rule. So when you stretch your thumb, forefinger and middle finger in such a way that they are mutually perpendicular to each other, and forefinger shows the direction of magnetic field and middle finger shows the direction of current, then the thumb will show the direction of motion of the conductor. And on the basis of this, the working principle of motor is explained. Electric motor is a device in which electrical energy is converted into mechanical work. Means when electric motor is placed in a magnetic field and the current passes through it converts electrical energy into mechanical work, and it is based on the basic principle of Fleming left hand rule. Now see, electric motor is based on the basic principle that a current carrying conductor placed perpendicular to the magnetic field experiences a force, and the direction of force or the direction of force is determined by the Fleming left hand rule, which I have already explained. Okay, when you stretch your left hand and take out the forefinger, middle finger and thumb in such a way that these three fingers are mutually perpendicular to each other. If the forefinger shows the direction of magnetic field and the middle finger shows the direction of current, then the thumb will show the direction of motion. So electric motor is based on this principle only, that when a current carrying conductor is placed perpendicular to the magnetic field, it experiences a force, and this direction of force is determined by the Fleming left hand rule. This is the working principle of electric motor. You know that in your household uses, in several equipments, electrical equipments which you are using electric motors, that water pump, mixie grinder, fan, in many other things you are using the electric motor, where it is used in our daily life. Now next part is electromagnetic induction. Electromagnetic induction means how the magnet can induce electric current or you can say the flow of electric current in the circuit. For this, Michael Faraday has done an experiment that what he has done, he has taken a hollow metallic tube in which wire is coiled around it, and here the galvanometer is attached to it. And a magnet is taken, a bar magnet. What happens? When both this coil and this is the magnet, when both are at rest position, there will be no deflection in the galvanometer. Then make the coil at rest position and you move the magnet closer to the coil and away from the coil when you move the magnet close to the coil and move away from the coil, then what you will see, a deflection is shown in the galvanometer. Again, you keep this magnet at rest and try to move this coil towards the magnet and move again away from the magnet. Then also deflection in the galvanometer is shown. See, this means that either the coil or the magnet, any of the two, is in a moving condition. Means when you move the magnet or you move the coil, deflection is observed in the galvanometer. It means that some current is induced in this coil due to this movement of the magnet or movement of the coil towards or away from the magnet. This concludes that whenever a coil is rotated under a strong magnetic field, whenever a coil is rotated under a strong magnetic field, a current is induced in that coil, and that is called electromagnetic induction. So, as per Michael Faraday experiment, the definition of electromagnetic induction, you can say that the phenomenon of producing induced current in a closed circuit or coil due to change in magnetic field in the nearby circuit or closed coil is known as electromagnetic induction. Means you have seen that in Michael Faraday experiment, either the coil or the magnet, any one of is in moving condition, then the deflection is shown in the galvanometer. This shows that a current is induced in that coil, and due to the movement of magnet or the coil, they changes the magnetic field, and the direction of this induced current is determined by again Fleming's right hand rule. In the Fleming's right hand rule, what we do, we again take the three fingers, forefinger, thumb and the middle finger in such a way that they all three are mutually perpendicular to each other, in which the forefinger shows the direction of magnetic field and the thumb shows the direction of rotation of the coil. Then the middle finger will show the direction of induced current produced in the circuit. and the electric generator works on this principle only, where the mechanical energy is converted into electrical energy. Means when a coil is rotated under a strong magnetic field, a current is induced in that external circuit attached to that coil, and the direction of current induced in the circuit is determined by the Fleming right hand rules. So only working principle is in your syllabus. Construction and working of motor and generator is not, it is excluded from your syllabus. So only working principle I am explaining, that whenever a coil is rotated in a strong magnetic field, an induced current is produced in the external circuit of the coil, and the direction of the induced current is determined by the Fleming's right hand rule. Now let us start another topic, that is safety measures in using electricity. You know the children, in your house hold electrical circuit, how they are connected? They are connected in parallel connection. Means you have observed, if your fan is not working, but in that room other electrical equipments are working, means all the connection connected in the household wiring, they are connected in a parallel way. Now here we will discuss about the safety measures. What are the safety measures which we will use while handling the electrical appliances or while handling the electrical gadgets? The first of all, the first safety measures is that electric fuse. You have heard the word electric fuse. Electric fuse is a safety device which is always connected in a phase wire of the electrical appliances. It is consists of a thin wire either made up of copper or aluminium or alloy of tin and lead. This device is connected in the phase wire because it prevents our wiring from damaging whenever the high current flows through it. How it prevents? Suppose here we are seeing the equipment's socket. This socket has a rated that 5 ampere of current will flow through this circuit. If we connect an electrical appliances which can withdraw more than 5 ampere current, then what will happen? Due to the high current flowing, high heat energy will produce and this socket will get burned. Means in a similar way, the fuse has a certain rate. Means if you are using a fuse of 5 ampere rating and as soon as the current flowing through that fuse is more than 5 ampere, then what happens? This fuse wire is very thin, of high resistance and low melting point. So due to the flow of large current, what will happen? The temperature will raise and this the melting point is very low. The wire, fuse wire will get melt and it will break the circuit and it will prevent our wiring. So in each and every appliances, how much current is withdrawn, that is already given in the circuit, and according to the current withdrawing from the appliances, lower than the current withdrawing from the appliances, little bit higher rate of fuse is inserted in that appliances, so that that appliances should be safe. So electric fuse is a device. It is a safety device which is used to prevent our electrical appliances. Now, second precaution what we should do, the PVC coating on the wire. You have seen that wire is coated with the PVC, polyvinyl chloride. That coating must be so strong that when a current passing through the wire, that coating should not be melted due to the heat produces in the wire. Third precaution we should take, that we should never touch any electrical appliances or electrical wire with barefooted. नंगे पांव कोई भी इलेक्ट्रिक तार हमें नहीं छूना चाहिए. Also we should not touch with our wet hand also. Now, fourth safety measure is earthing. You have heard the word earthing. What does it mean? Earthing. Have you seen the earthing? Whenever you see a socket at your house, you have seen that one is neutral, one is phase, and another third hole is at the top is given. That is the earth wire terminal is here. What does this earthing do or does? How does this earthing help us from getting electrical shock? You know that at your house, you are not purchasing AC or fridge or mixer grinder or any other heavy appliances regularly. You very often purchase. Means एक बार आपने फ्रिज खरीद लिया तो कम से कम 15 से 20 साल आप यूज करेंगे. इलेक्ट्रिक आयरन खरीद लिया तो वो कम से कम 5 से 6 साल 10 साल भी यूज करेंगे. ऐसा नहीं कि आज खरीदे हैं अब 15 दिन बाद आप उसको खत्म हो जाएगा, खराब हो जाएगा, उसको फेंक देंगे. ऐसा नहीं करेंगे. Whenever you purchase heavy electrical appliances, that is micro oven, fridge, AC, refrigerator, at least you should use that appliances for many years. And you have seen that the plug of that appliances has 3-pin plug. Like this 3-pin plug. Now you see, in all the heavy appliances, the wire connected in the 3-pin plug, that is, one is neutral, one is phase wire, another is earthing wire. This terminal is connected to the earth wire. Now let us see what is the use of these earth wire. What happened? You know that most of the heavy appliances, electrical appliances such as fridge or micro oven, their body consists of metallic body. Now, in a long run of using these appliances, sometimes what happens? The insulation of the wire inside the metallic body gets removed somehow and it touches to the metallic cabinet or the metallic body of the appliances. Now, when we insert that plug in the 3-pin plug in the socket, and when you put it on, the current will start flowing, and that too also the current will flow to the metallic body also. Why? Because the insulation of that wire has been removed and it is touching to the metallic cabinet of the gadget. So the current will flow there. If there is earthing connected to your wiring, then this leakage current will straight away pass to the earth, that is ground, without giving you any electrical shock. So in this way, earthing wires save us from giving electrical shock. Now listen, how this earthing should be prepared. आप क्या देखते हैं कि घर में आप किसी नल में जाके एक तार बांध दिए, वो अर्थिंग हो गई? नो, दैट इज नॉट द वे टू प्रिपेयर अर्थिंग. फॉर प्रिपेयरिंग एन अर्थिंग, व्हाट वी हैव टू डू, वी हैव टू मेक अ बोरिंग एटलीस्ट 100 feet or 75 feet or more than 100 feet. And in that boring, what we do, we put a metallic pipe inside it and some activated charcoal is placed and some salt is also placed in that boring, and then a iron rod or a copper rod is dipped in that boring whose half part is above the ground and 90% part of the that metallic copper rod is inside the ground, and that is piled up, and the part of the metallic rod, copper rod, which is above the ground, will act as an earthing, and that earthing is connected to our electrical wire. So in this way you can make a proper and good earthing. So these are the safety measures. So these are the some safety measures which you can take during the use of electrical appliances. One more safety measure is that during lightning and thunderstorm, we should put switch off our TV, all electrical gadget, mobile phone. We should switch it off when there is a heavy rainfall or thunderstorm is occurring. Now, beside these safety measures, two more terms are there. You have heard it about short circuiting and overloading. Short circuiting and overloading. Short circuiting means whenever the phase wire comes in direct contact with the neutral wire, then short circuiting occurs. Means जब भी कोई फेज वायर जो न्यूट्रल वायर से टच कर जाता है, तब शॉर्ट सर्किट अपीयर करेगा, ड्यू टू द विच लार्ज करंट फ्लोज एंड इट मे रिजल्ट इनटू द इलेक्ट्रिकल फायर आल्सो. शॉर्ट सर्किटिंग में रिजल्ट इनटू द इलेक्ट्रिकल फायर. ऑफन यू हैव हियर, अरे उसके घर में भी आग लग गई बिजली से, शॉर्ट सर्किट हो गया. शॉर्ट सर्किट मीन्स व्हाट हैपन whenever the phase wire comes in direct contact with the neutral wire, a short circuiting takes place. Another term is overloading. By the term you should know overloading. Overloading means, you have seen in general term also, overloading means when you move on a road, you see some of the passengers are lying above the bus. Inside the bus also there is passenger, and above the bus, on the roof of the bus, the passenger is also sitting. Then you can say that देखो वो बस में overloaded हो गया. Means the अपने कैपेसिटी से ज्यादा उस पे लोड पड़ रही है. That is called overloading. Here also in electrical term, overloading means the capacity is increases than their own capacity. Suppose in this socket, in a single socket, we put into more than 2 or 3 extension cord here. Plug. By plugging into the 3 plug and 2, 3, 4 टर्मिनल्स हम निकाल दे, और इसकी कैपेसिटी कितना है? Only to withdraw 5 ampere current. And if we are withdrawing more than 5 ampere current, that means this socket is under the overload and it will get heated and burned. So with overloading means if the capacity increases than their its own capacity, then you can say that that is overloading. Suppose in your household, if you are using a converter or inverter of 500 watt, and as soon as the current shut down, you start switching on all the appliances, what will happen? The supply of your house is more than 500 watt. So what will happen? A beep sound will hear from your inverter machine. It means that your inverter or converter is overloaded. अगर 500 वाट की कैपेसिटी है तो उसे हम बिलो 500 वाट तक की कैपेसिटी उस पे दे सकते हैं. इफ वी इंक्रीज more than 500 watt capacity on that converter or inverter, then what will happen? It will start blinking and it may go off or it may shut down all of a sudden. So overloading means, you know that means if the capacity is increases, then there is on capacity, that is called overloading. So to avoid overloading, we should use a proper gadget or proper socket for proper withdrawing of current from the circuit. So children, I hope you are able to understand what are the safety measures which you should take using the electrical appliances, and also what is the working principle of electric motor and electric generators. That's all for today. Hope if you have any confusion, you can ask during the questionnaire period. Thank you. Have a nice day, children. We will meet you again in the next class. Thank you. Have a nice day.